Application problems, number 2. The diagram at the left, well in this case the diagram below, shows the cross-section of a satellite dish where x and y are measured in meters. Find the width and depth of the dish. Okay, you guys take a look at that for a minute. We need to find the width and we need to find the depth. Okay, width means kind of like this way, how far across. Depth means kind of like this way, how far deep. Take a look, what do you think? And don't overthink it. They gave you the function y equals 1/4 x squared. They graphed it. And they want to know, first of all, how wide is this thing? So how wide is this thing? I'm thinking, okay, well, we're going from here to here. And one of the answers I usually hear is 8. It is 8 meters across. And then I go, no, because you're not paying attention to your scale. This point out here is at -2, 1. So it went -1, 2, 3. Yeah, it kind of looks like 4, but it's not. It went by half. Half -1. -1.5. This is really just out at -2. This is really just out at 2. So if we went 2 this way and 2 this way, the width, 4 meters. Depth. Take a look at your depth. Same thing. I usually hear 2. No, you're not paying attention. Okay, so this actually went up a half and then 1. So your depth is 1 meter. And I'm just going to let that go. We're not going to overthink that one. Let's go look at our next one. Number 3. Let f of x equal -0.5 x squared plus 2 and g of x equal f of x minus 7. Letter A, describe the transformation from the graph of f to the graph of g. Then graph f and g in the same coordinate plane. Write an equation that represents g in terms of f. Okay, pause the video, try to figure out what the heck they're talking about. But the first thing, once you're done unpausing, letter A, describe the transformation of the graph of f to the graph of g. So here's f, and then here's g. And g is saying, take f and do this. Well, what is that? Is that a vertical stretch or shrink? Is that a horizontal left or right? Is that a vertical up or down? And the answer is it's a vertical up or down because it's just a -7 on the back. So just like graphing where we added 2 when we moved the parabola up 2, we would just graph this thing and move it down 7. So describe the transformation of the graph of f to the graph of g. It is a vertical shift down 7. Then graph f and g in the same coordinate plane. So let's see, that one went up 2, that one went down. I'll just do this and hope I have enough. So I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Okay. First graph, f of x. We have a parabola, so we're going to make a U. This one says up 2. Up 2. So I'm going to start at 0, 0, but I'm going to go up 1, 2, and I'm going to put my vertex. Then the -0.5 says over 1 down, because it's negative, 1/2 or 0.5. So I'm going to go over 1 down 1/2 over 1 down 1/2. And then I'm going to make it appear a little bit wider maybe than my typical parabola because the 1/2 is a vertical shrink. Then I have to graph g of x, which means take, this is what this is saying, take f of x and move it down 7. Okay, so it's right here. I'm starting up here at 2 and I'm moving down 7. 1, 2, 3, 4, 5, 6, 7. So my vertex is actually right there. And right there is a very important part. You're gonna have to figure out where that is. And then keep everything else the same. Just take the graph, move it down 7. So we're still going to go over 1, down a half, over 1, down a half. And again, if you try to make the other one a little bit wider, you're going to try to make this one a little bit wider. And I'm not perfect at freehanding things here, but it should literally be the same graph moved down 7. Now we have to write in part B, write an equation that represents g in terms of x. Meaning up here in this red box we have g of x, but right now it's in terms of f of x, and I don't want that. I want it to look like just a normal function. So g of x equals, take a look at the red graph. What would the function be if we didn't just have f of x there? Well, first of all, we know that it goes over 1 down a half, so we're going to keep the negative 0.5 x squared because that's what the other graph did, and that's what this graph does. But we have the vertex down here, and the question is, where is that vertex? Negative 1, negative 2, negative 3, negative 4, negative 5. So that vertex is actually down here at negative 5. Or we could have taken a positive 2 up here and subtracted 7, which positive 2 minus 7 is negative 5. And there is your equation for g of x in terms of x versus being in terms of f of x.